kids, here we go. In this lesson, topic 6.2, we are going to be finding the least common multiples for a set of numbers, or a number, or set of numbers. So what we're going to do is take some notes, and what I would like you to do is to open your notebook and your math book and get ready to go. All right. Now, before we start talking about finding the least common multiple, we want to remember that another way of asking for the least common multiple is to write LCM, least common multiple. Now, before we go into the actual lesson, let's just make sure we know the difference between factors and multiples. So let's write down the number 8 in our book, okay? And if we want to talk about the multiples of 8, okay, we would be talking about 8 times a number to get a product. So multiples are the same as products, okay? Multiples are basically the same as products, and you're going to use 8 as a factor to multiply another number. All right, so in this case, it would be 8 times 1. 8 is a multiple of 8. And then if we have 8 times 2, we would see that 16 is a multiple of 8. All right, if we had 8 times 3, we would have 24. 24 is a multiple of 8, okay? So these are factors, okay? And the products are multiples, okay? So these are all factors, all right? And they would be used together to create multiples, all right? So that's an important piece of information right there. And to show it more simply, okay, to make it really distinguishable, if we write 8 down and then we say, okay, what are the factors of 8 and what are the multiples, what are the multiples of 8? We could say the factors of 8 would be any number that can be multiplied with another number to get 8. So 1 times 8 is 8. 2 times 4 is 8. 8 times 1 is 8. And the factors, n. Multiples, on the other hand, if we did 8 times 1, we'd get 8. 2 times 8, we get 16. 3 times 8, we get 24. 4 times 8, we get 32. And it goes on and on forever. So these are limitless. Okay, they go on forever, limitless. All right, so that's the difference between multiples and factors. Now, just like finding the greatest common factor, there are 2 ways for finding an LCM, okay? Just like finding the GCF, there are 2 ways for finding the LCM. The first method is the list method, okay? The first method is the list method. And you can probably guess the next method. It is the prime factorization method. These are the 2 ways that you can find LCMs for numbers, okay? So now we're going to take a look in the book and see how the book talks about finding a least common multiple. All right, least common multiples. How can you find the least common multiple of 2 numbers? Grant is making picnic lunches. He wants to buy as many juice bottles as applesauce cups, but no more than he really needs to get an equal number of each. how many packages of each should Grant buy? Well, juice bottles are 6 per pack, and applesauce cups are 8 per pack. Okay, so we want to find the LCM for 6 and 8. And we can use either the list method or we can use prime factorization. And the book shows us that. It shows us one way is to list the multiples of each pack size. Okay, so we have 6, and so we would go 6, 1 times 6 is 6, 2 times 6 is 12, 3 times 6 is 18, 4 times 6 is 24, 5 times 6 is 30, 6 times 6 is 36, 7 times 6 is 42, 8 times 6 is 48, and then on and on forever. Multiples of 8, 8 times 1 is 6, 8 times 2 is 16, 8 times 3 is 24, and at this point you're saying, whoa, there's the least common multiple. But if you go on and you have 4 times 8 is 32, 5 times 8 is 40, 6 times 8 is 48, you'll see another common multiple, okay? 24 and 48 are both common multiples of 6 and 8. So those are 48 and 24 are both common multiples, but we want the least common multiple, which is going to be 24. So the common multiple with the least value is 24. And if you look down below, you'll see that 4 packages of juice, okay, you would multiply 6 times 4 to get 24, and you need 3 packages of applesauce. 3 times 8 is 24 because you get 8 cups in the applesauce, and you get the 6 in the juice. All right. So, anyways, that's how you would find the list method. Now, here's something to think about, though. Sometimes, and you don't have to bother writing this down, but remember, some people think if you want to find the LCM for 2 numbers such as 6 and 8, you could just simply multiply 6 times 8. Well, that certainly gives you a multiple, but that is not always going to be the least common multiple. Sometimes it will, sometimes it won't, and in this case, you can see that it is not the LCM. All right? So now let's take a look at the other method using prime factorization. All right? If we use prime factorization, okay, circle the greater number of times each different factor appears. So if we make a factor tree for 6, and we say, okay, we have 2 times 3 is 6, and our factor tree ends. We have 8. We have 2 times 4 equals 8, and then branch down 4, and we have 2 times 2 equals 4. So now we have the prime factorization. We want to find the numbers, circle the numbers with the greater number of times each different factor appears. So in other words, we'd say, okay, well, we have 2 here, but we have 2 over here also. We have 2 3 times under 8, so we're going to use the 2's from 8. All right, so that's where we get our 3 2's. And then if we look over here, we say, well, we have 3, but we don't have any 3 over here, so we're going to use the 3 from 6. And that's how we end up with our 3, okay? And so we have this 3, and we have our 3 2's, and we multiply them out. And of course, if you do that, you have 3 times 2 is 6. 6 times 2 equals 12, and then 2 times 12 equals 24. All right? Don't write in your book like that, okay? But you can see how we use prime factorization. All right? So anyways, what we're going to do is we're going to try a couple examples right now on our own in our notebook. Our first example is to find the LCM for 5 and 6. So you'll want to write this out in your notes, and I will pause the video, and we're going to use the list method for this example. All right? So go ahead, I will pause the video, and you see if you can find the least common multiple. I will pause the video now. Alright, here we go. Let's check out and see how we did. Alright, we're going to find the multiples for 5 first. 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15, 4 times 5 is 20, 5 times 5 is 25, 6 times 5 is 30, 7 times 5 is 35, and on the list goes. The multiples of 6 that we would list would be 1 times 6 is 6, 2 times 6 is 12, 3 times 6 is 18, 4 times 6 is 24, 5 times 6 is 30, 6 times 6 is 36, and on and on and on. Okay? So now we can identify the least common multiple, and that would be 30. Alright? That would be 30. And in this case, 5 times 6 actually does yield the LCM, but it doesn't, that's not always the case. Alright? That's not always the case. Alright, let's try another example, and again, let's use the list method for this example. Alright, I will pause the video now. Okay, let's see how we did here. Okay, let's list a couple multiples for 4. 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, 4 times 4 is 16, 5 times 4 is 20, 6 times 4 is 24, 7 times 4 is 28, 8 times 4 is 32, 9 times 4 is 36. We've got to go pretty high here. 10 times 4 is 40, and we can stop right there, but it would go on and on infinitely. Multiples for 10. Alright, we can stop when we find the least LCM. We have 1 times 10 is 10, 2 times 10 is 20, 3 times 10 is 30, 4 times 10 is 40, and so we have our least common multiple right there. And again, this is another example where you could multiply to get the LCM. Okay, you could multiply to get the LCM, but that's not always going to work. Now we're going to use prime factorization to find the least common multiple. Okay? Find the LCM for 8 and 12. And in this case, you can use prime factorization as well as the list method. Okay, so let's actually use both methods, prime factorization and list. I will pause the video now. Alright, here we go. Let's see how you did. Let's use prime factorization first. Okay, so we have 8 and we have 12. Well, the first layer in 8 is going to be 2 times 4. And then 4 will be broken down into 2 times 2. We have the prime factorization of 8. If we find the prime factorization of 8, we do 2 times 6, and then our next branch would be 2 times 3. And you can see now that again, what we have here is we have our numbers that appear the most, okay? So we have value of 2, and 2 appears the most in the 8 tree, so we would have 3 2's, so we'd have 2 times 2 times 2, and then 3 appears once in the 12 tree, so we would have to multiply by 3, and if we multiply that out, we get 2 times 2, whoops, we get 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24, or you could write it as 2 to the third times 3 equals 24. Now, if we were to list these out, you could see that we would list them out. We'd have 8, 16, 24, 32, and we would have 12, 24, 36, and our LCM would come out as 24. And certainly, if we multiplied 8 times 12, you are not going to get 24. So in this case, just multiplying the two numbers will not give you an LCM. All right, let's try another example. All right, try using both the list method and prime factorization. I will pause the video now. All right, here we go. Let's see how we did. All right, in this case, all right, we want to list the factors for 14 and find the prime factors for 14, which would be 2 times 7 gives us 14. Then the prime factorization would start with a 2 times 6, and then 2 times 3. And then what we want to do is we want to circle the primes by the greatest value and the highest count. So in this case, you can see that we have 2, but we also have 2 and 12, and we have more 2's in 12. We actually have 2 12's. And then over here, you'll see that we have 3, all right? So we've got to use 3 as well. But we still have 7 here, so we're going to use 7 as well. So you can see that we're going to have 7, we're going to have 2, we're going to have another 2, and we're going to have a 3, all right? So this is what our prime factorization sets us up for. We will have 2 times 2 times 3 times 7, which equals 48. Or you can write it as 2 to the second times 3 times 7 equals 84. I'm sorry, 84. If we listed, we would have 12, 24, 36, 48, 60, 72, 84. And then we would have 14, 28, 42, 56, 70, 84, and so if we use the list method, we get 84. And you can see that with numbers like this, sometimes it's easier just to use factor trees. All right, let's try another example. Find the LCM for 16 and 15. I will pause the video now. All right, let's see how we did. All right, and you can see that there's some, if you tried the list method, you probably saw that you had a seriously long list for each set of numbers. All right, so let's make a factor tree for 16. We do 2 times 8, then 2 times 4, and then 2 times 2. So now we've done the prime factorization for 16. For 15, the prime factorization is simply 3 times 5. All right, so now we can identify the numbers in the prime factorization. You can see that we have 2 over in 16, but there's no 2's over here, so we're going to use the 2's from 16, and we end up with 4 2's, or 2 to the 4th power. Then we're going to come over to the 15 factor tree, and you can see that we have the factor of 3, prime factor of 3, and then we have a prime factor of 5 as well. So now we know that we're going to have 2 times 2 times 2 times 2, 4 2's, times 3 times 5, and if we multiply that out, you'll see that we have 240, okay? If we used exponents, it would be 2 to the 4th times 3 times 5, and that would equal 240 as well. Now, if you look at the list method and you started to list, you would have to do some serious listing all the way up there, okay, before you actually found 240. So if you wanted to really find the least common multiple for those two numbers, the best way of doing it is prime factorization using your factor trees. You could very easily make mistakes if you use the list method in this situation. Okay, so that's it for finding the least common multiple. And what we're going to do now is we're going to start talking about the 6-3 concepts. Okay, so we're going to do some thoughts and skills on topic 6.3. So why don't you write this down in your notebook right now so that when you get to this lesson tomorrow or the next day, you kind of have an understanding of where we're going and you already have learned a little bit about it. Okay? All right. What you were going to be talking about from here on out is how to divide fractions by fractions and whole numbers by fractions and fractions by mixed numbers and that sort of stuff. And one of the things that you're going to need to know is what a reciprocal is. Okay? Now, a reciprocal just simply means that when you multiply two amounts, you get a value of 1. Okay? So if I were to give you 2/3, so you would write this down in your notebook, 2/3 would have a reciprocal that you can multiply it by in order to get a value of 1. Okay? So the reciprocal of 2/3 would simply be 3/2. And all you really do is you just switch around the numerator and the denominator to create a new fraction. And then when you multiply those together, you would see that 2 times 3 equals 6. 3 times 2 equals 6. 6 equals 1. All right? So another example would be 7/8. And this will work for any fraction. The reciprocal of 7/8, all right, what do you think it would be? All right, you can write it down if you know. If you don't, here it is. It's 8/7. And again, when we multiply this out, we see that 7 times 8 is 56. 8 times 7 is 56. And 56 just equals the whole number 1. So that's what we mean when we talk about a reciprocal. Okay? It's just a matter of inverting the numerator and the denominator to get an amount that will eventually equal 1. Okay? All right, the next thing that we're going to need to know before we go on in this unit or topic is what does it mean to cross simplify? So we've already talked about this, and we know that simplifying happens at the end of a problem when we're multiplying, adding, subtracting fractions. Okay? So if you have a problem such as this, okay, 2/4 times, let's say 8/12, you would get an answer, okay, you would get 2 times 8 is 16, and 4 times 12 is 48. And then this answer would have to be simplified before you finish your problem. So that means that you would have to find the GCF for 16 and 48. Okay? So in this case, you would know that the GCF is actually 16, okay, if you found it. And so 16 divided by 16 is 1. 48 divided by 16 is 3. Well, when you cross simplify, you could say to yourself, well, geez, 8 and 4 are compatible. 4 will go into 4 divided by 4 equals 1. So we can make that 1. 8 divided by 4 equals 2. So we can make that 2. And then 12 and 2 are compatible. 2 will go into 2. 2 divided by 2 equals 1. So that could become 1. 12 divided by 2 equals 6. So 12 divided by 2 equals 6. So 1 times 6 is 6. 1 times 2 is 2. And so we end up with a fraction of 2/6, which is still not simplified. Okay, it's still not simplified But this is a lot easier to simplify down into simplest forms if we divide by 2 and we get 1/3, okay? And so rather than trying to figure out the GCF, a lot of times we can pre-simplify doing this cross-simplifying, okay? We'll give you another example of that you can try on your own right now. Let's go with 5/8 times 2/15. See if you can cross simplify that and then multiply it out for the answer. I will pause the video now. Alright, let's see how we did. Alright, so if we were to actually do this problem, we do 5 times 2, we would get 10, and we would do 8 times 15, which is, we probably have to do that on scrap paper or use a calculator. 8 times 5 is 40, carry your 4. 8 times 1 is 8, you get 120. Wow, then we'd have to simplify that. And we'd find the greatest common factor for those two numbers, and we'd simplify them all down, which would be 10, and that would give you 1, and divide that by 10, that would give you 12, so it would be 1/12. But if we cross-simplify, look what we get. Okay, if we cross-simplify or pre-simplify, 5 and 15 are compatible numbers. 5 divided by 5 is 1. 15 divided by 5 is 3. 8 and 2 are compatible numbers. 2 will go into 2 one time. 2 will go into 8 4 times. And now when we multiply across, you'll see that 1 times 1 equals 1. And 4 times 3 equals 12. And so we end up with a simplified answer right when we need our answer. Alright? So anyways, I'm going to set you to work on your practice problems now. If you have any questions, you can see your teacher or parent.